reminder when submitting assignments. So this is just a reminder about the assignments. By uploading your code to GitHub, this will allow you to share code for assignments easily. Please make sure to copy and paste the uploaded code into the form. Yeah, so that's that. Because the video has gone out later to you guys for session 3, don't worry if you haven't done that yet and you do that a bit later, that's absolutely fine. If you have done it, that's awesome. But if you do it a bit later and you submit it, that's not going to impact anything. So don't worry about that. Just get the assignment done when you can. And if you needed the recording, that's absolutely fine. But from now on, the recordings will be sent out more promptly. Okay. Right. I saw Layla, you raised your hand. I don't know whether that was a mistake or if you had a question.
Sorry, it was a mistake. I was trying to remove the thumbs up.
Okay, no problem. That's fine. Anyone got any questions so far? Is everyone okay? Okay, I think everyone's okay. So I'll move on. Right. So that's the recordings. Right. So if you're coding on a laptop or tablet, we recommend the Replit app. So this is the Replit app. I would ideally say code on a computer if you can, but if not, then this is absolutely fine. Right, let's dive into today's session. So we're going to continue to build on top of last week's work. We're going to understand the fundamentals of dictionaries and sets. Again, mainly the priority is going to be dictionaries. We're going to apply dictionaries and sets in practical scenarios, and we're going to implement hashing and data integrity concepts. So I'll go over what hashing is, why we hash, as well. So again, if none of those words are familiar to you, don't worry. Dictionaries are a lot. It's relatively exactly what you think, just in a coding sense. And hashing we'll go over, and by the end, you should hopefully be familiar with everything. Right, so what we're going to build today. So today we're going to create a basic password manager using dictionaries. So a password manager in the sense of it's kind of like your iPhone. It can store all your passwords for all the different websites, and then you can check whether the password you have for a website is in there. So in case you forget it, it is listed in there for you. Okay. But we're going to create a simple version. It's going to display a message to the user asking for a website or application name. We're going to allow the user to input their password for the corresponding website or application. We're going to check if the password entered is correct or not for the given website or application. So a reminder, you're not expected to memorize everything we cover today. That's fine. Just go over it in your own time. And also with the recording. And also we've got a Saturday session if you do want to ask any questions. So first, we're going to open up either Replit or Trinket. So I'm going to let you guys do that. I will send a link for Trinket in just a second.
Hi, I just wanted to say I'm using my computer and I'm using W3 Schools, but that means I can't copy and send you right now what I've done. But if something doesn't run, I'm sorry, it's just I think it's the easiest way than me trying to move my iPad back and forth between screens, which takes unnecessary time up. But I just wanted to let you know.
That's fine. If you do want to try and use Trinket, that website's a lot easier because you can then just share the code with me.
Oh, okay. Let me try that.
Yeah. So I've just
I
sent
didn't realize you could do Trinket on the internet. Let me just see because okay. Let me see. Yeah. Let's go for it.
Perfect.
Oh, I've got to sign up for an account. Oh, okay.
You don't need to. You don't need to create an account. You could just code straight right away. If you open up the link, it should just land you here.
I don't. I can't link the link from the screen to my.
Okay. So it's just trinket.io/Python3.
I think Python is quite frustrating insofar as you can copy and paste it to your code to something else, and it stops working because the indentation is slightly skewed.
Yeah.
I think it's a bizarre language because of it's interpreting the spacings for the syntax.
Definitely. Yeah, different interpreters do run things differently. Some prefer four spaces, some prefer tabs. So yeah, usually if the indentation is consistent throughout, it should be fine, but sometimes it does run into an issue. What sometimes negates the issue is rather than copying and pasting, if you download the code as a PY file and then upload it as a PY file, then it usually fixes things. So that is a workaround. But if you're coming from a language like Java or C++, where the spacing doesn't and indentations don't really matter too much, and you can get away with it being different as long as you're using the right curly brackets, then yeah, I can see why it would be a bit harder or more frustrating. Right, so hopefully we managed to get Trinket up now. So yeah, trinket.io/Python3, and you should just land here and you should be able to run. Perfect. Right, so first, what is a dictionary? So dictionaries are unordered collections of unique values stored in key value pairs. So I know that's a lot of words to digest there, but essentially it's similar to a list in that you store information, multiple pieces of information in one place. So if we remember our list lesson, we used square brackets and we stored our shopping list inside. So here you can see a dictionary which uses curly brackets and it stores items with a key value pair. So you can see here, you've got A, the value of A is 10, the value of B is 20, the value of C is 30. So to visualize this and why it's called a dictionary is it's kind of exactly like a dictionary. So when you use a dictionary to look up a word that you don't know the meaning of, you've got the key, which is the actual word, and then you've got the meaning next to it, right? And that doesn't change here. So it stores something, a key with a matching value. Okay, so that is the way, and then it's separated by commas. Now, our keys, in order to access them, rather than it's unordered. So it's not like a list where this is the first item. So this is item 0, this is item 1, this is item 2. It doesn't work like that. To access an item, you specify the index and then you get the value. So you specify the key. So the dictionary, and then you square bracket, similar to a list when you're trying to access it. And you say, instead of, if we said in a list D0, that would be the first item, right? But here we say DA and we get 10, DB and you get 20, D3 and you get 30, etc. So the key things to note are that the items in the dictionary are stored without any index value. So it doesn't count 0, 1, 2. It doesn't work like that. Keys in the dictionary should be unique. So you can't have A value 10, A value 20. It doesn't work like that. It has to be unique keys. And mutable. So you can add, remove. So it works similar to a list where you can actually change it. It's not like a tuple where you can't. Okay, so you can amend things in here. Is everyone with me so far as to how a dictionary works? Do we have any questions? Okay, I'm seeing a lot of thumbs up, which is good. Right, if we don't have any questions, I'm going to move on to the next part. This is relatively straightforward. Right, what is hashing? So when we store information, certain information, we want to sometimes hash it, encrypt it, so that when it's being stored, if anyone were to access that information, without the actual hash function, they're not going to be able to decode it. Okay, so we have a plain text, we have a hash function. So in this case, we have SHA-2, we can have different other ones as well. And then you get a bunch of hash letters. So you could see here, you've got a key, so A, and it goes through a hash function, and then you can see it gets matched up to perhaps 4, and then this is the item that is being stored. So James will be stored as 754231, for example, or FF7 something, so that when it's accessed, it doesn't it's less prone to being hacked, basically. So let me just open up this a little bit of information here on what hashing is. So it's the process of converting data, text, numbers, or anything into fixed length string. So that's important, of letters and numbers. So it's converted into fixed length strings or hash values by using a special algorithm called a hash function. Okay, so the input is the key, input data, and then you get an actual value for it. Okay, so I'm just going to skip through this bit. And these are some of the properties. So it's deterministic, it's quick computation, it's irreversible. Yeah, so the difference between hashing and encryption is that you can't decode it. Once it's a hash function, it's a hash function. You can compare it to check if a hash function is that same hash function if you convert two things, but you can't decrypt it and work out what it was originally. So it's really good in terms of data authentication. Okay, so it's really good at detecting changes in data. So why is it used? So it's secure. So that's the first thing. Detecting changes in data. So you can see here, right, I'm gonna just do this. I want you guys to have a look actually. Right. This is one sentence and this is another sentence. Can you tell what the difference is between both of these sentences? So ignore the numbers for now, but just these two sentences between the speech mark. Just put it in the chat for me. What is the difference between these two sentences?
You mean the spelling mistake, or what do you mean?
Yeah,
Okay.
Code Academy.
that's it. Well done. So it's really hard to tell. It is absolutely really hard to tell. And at first look, you might think, what? It looks exactly the same. But you can see here, this is spelled with an E and this is spelled with an A. Okay? You got a spelling mistake. Now, that was quite hard for us to go through and look at on first glance, isn't it? But when we hash it, this is the hashed value for this particular string. Now, this is the hash value for this particular string. And these two are completely different. So we know that there's a mistake because if it was the exact same, we would end up with the exact same hash value. So literally on quick glance, we can tell that these two are, there is something different about these two sentences and they're not the same. Okay? So that is another reason why we use hashing as well. So it's good for, if you're working with non-sensitive data, sensitive data you wouldn't compare, but if it's non-sensitive data, so nothing, something that's not like a password, just something that you're storing like a username or whatever, it maybe not even a username actually, just a sentence, then you would compare these. It's extremely private. You won't be able to retrieve, and when you retrieve it, you won't be able to actually work out what it is. Yeah, so there's loads of popular hashing algorithms. There's MD5. It was the most common, but not really as much anymore. And you've got secure hash algorithm. This is the one we're going to be working with today. It refers to a group of hashing algorithms. SHA-2 was developed by NSA. And it's currently used by cryptocurrencies and the CIA. And you've got CRC32 as well. Right. So it's very valuable within cybersecurity and database management. And the reason why we're going to be looking at it today is because we're building a password manager. So when we store our passwords, we don't want to store it as the password itself because that is very insecure. We want to store it as something else that that is stored so that when we look at it, it is completely different. Right. But should we need to check, we are able to. Okay. So, right. Let me just bear with me 1 second and we're going to get started. Okay. Right, so the first thing we're going to do is we're going to import a function called hashlib, okay? And the reason why we're importing it is rather than writing a hash algorithm ourselves, which you can do, you can make a hashing algorithm yourself, we're going to import hashlib, which allows us to use the SHA-2 one. So it's already secure, it's already built. All we need to do, import it in, and we can use that for our code. All right? So very simple. And then what we're going to do is, as part of our criteria, we're going to print out what the program does. So we're going to print, welcome to our simple password manager. Right. So what we're going to do following this is we're going to create a function that does this hashing for us. So the reason why we're creating a function is that if we ever needed to extend our program and we wanted to hash somewhere else as well, all we need to do is call the function. It separates our code out and it can be called whenever we need to. I know we've not looked at functions thoroughly, but you can read up functions in your own time if you've got some time. But function is a way of separating code out so that you can reuse it, and also that it's clearly separated in its own place so it's easier for readability. Okay. So what we're going to do is our function is going to, first actually, we're going to create somewhere to store our passwords. So our passwords are going to be stored in a dictionary. So to create an empty dictionary, we just, similar to an empty list, we write equals, and this time we use squiggly brackets. So it's the squiggly brackets. On my Mac, it's Shift and the square bracket to get that. I'm not sure on Windows, but it'll probably be something similar. Right. Now, to create a function, we're going to write def hashing, and that's going to be our, so def hashing or def hash. The hash password is going to be, this is our function. So similar to how print is a function, we're going to make our own function, and we're going to pass in a password, okay? So whatever the user passes in, that's going to be the password. So basically, we're kind of predicting what the user would pass in as this argument. And then we're going to work with that. So then when the user does use it, it will work absolutely correctly. Sorry. So I'm just going to write a comment on what we're doing here, or I'm going to write a comment throughout. So here we're going to so we're going to create an empty dictionary to store the username and passwords, and here we're going to do the thing. And after def hash passwords, we need to make sure you have a semicolon, and so the next bit will be indented. Okay, similar to a while loop, similar to an if statement. Okay, right. So our hashed password, so we're going to pass in a normal password. So we're going to pass in whatever the user enters, and we're going to change it into a hashed password. So we're going to say hashed password equals, and this time we're going to now import from the library in order to do this. So SHA-256. Right. So we're going to write hashlib to access this library. And we're going to say .sha256. So this is the 256 algorithm, the SHA-256 algorithm. And we're going to open our brackets. And we're going to do whatever the password is, which is the user's password, whatever the user enters. So that's going to be password. That's what we've called it. And we're going to write .encode, open and close my bracket. Okay, so what that's going to do is it's going to encode the password, and then it's passing it into the SHA-256 algorithm. Okay, now what we need to do is, because we want it, it's going to be a hex value. So we're going to write something here called .hex digest right at the end. Okay, so you're passing in the password, you're encoding it. You're passing it into the hashlib bit, and we're going to make sure we're going to write .hex digest at the end. Okay, so I'm just going to move this up so you guys can see more. Might just zoom out ever so slightly. Let's zoom in now. Okay, there we go. Yeah. So hex digest converts it into a hexadecimal format. All right. And that is a format that the computer can understand. All right. So that's all that bit does. Right. So what we're going to do after this is we're just going to return the hashed password. Don't worry too much if you don't understand exactly every little bit of this, because that's what the import does. That's what the import allows you to do. You don't need to worry about what this is doing. We know once you use this line, it will basically hash the password for you. Okay, the password is hashed, and then it's stored inside hash password. And then when the user wants it, we're going to return the hash password. So here the users enters a here nothing happens. This is just a function. So if we ran this right now, nothing would execute on the side. It will just print out this and then end. But when we call this function with a password, it's going to hash the password and return it. That's what that bit does. Is everyone with me so far? Does anyone have any questions? I can see a thumbs up. That's good. Great as well. Awesome. Amazing. Well done, guys. Right. Has everyone managed to write this bit yet? Or do you want me to pause for a minute?
Can you give me just a minute?
Yeah, of course. Perfect. Yeah. So I'm just going to give you guys a minute to just write that up. This def bit here, that's just how you define a function in Python. So if you see def, that means a function is being created.
Sorry, can I just ask, you used def hash password, and then the next line was hashed password. Was that because those are two different things then? Is that correct?
That's correct. Yeah. So this is the name of the function that we're using to hash the password.
Okay.
So this is the actual password that's being stored. All right.
Okay.
So this is what's actually being done to the password that we're going to do. So everything in here is part of this. This is just the process of hashing it itself.
Thanks.
No worries. Could have probably thought of something better to call it, to be honest. That was my fault. And if you do want to just test it, just press run. If this is all you see, welcome to Simple Password Manager, that's correct. That means everything's working fine. You're correct. If you see some red, that means you've done something wrong. So yeah, just that's just a quick way of testing it. Because right now we've made a function, but we've not called it. We've not told it to do anything. All right. So I can see Ingrid's finished. Does everyone else manage to finish? Can I move on? Just give me a thumbs up if you're okay with me to continue. Okay, awesome. Oh, amazing. Well done, nice, right? Okay, right. So now what I'm doing is I'm just pressing enter and I'm just getting out. So I'm back right at the end, right at the beginning of the program, okay? Because we're getting out of the function and now we're back onto the main program. So we're going to create another while true loop. So similar to last week, this just means it's going to keep going until we tell it to break. So at this point, don't press run because until we've written our break statement, if you do something, if you do run it, it will just create an infinite loop and it will go on forever and it will crash our program. So we don't want to do that. So just write while true, colon, next line, just don't run it from now, okay? Until we've done our true statement. until we've done our if statement to break out of it. And the reason for this is we want our program to keep going. So it's part of our main program loop. So just here, actually, I'm just going to write a comment. So we're going to ask the user to save usernames or passwords using the program, okay? Because the part of the password manager is first we need to actually store them before we check them, right? So while true, the first thing we want to do is we want to ask if the user has a website that they want to save a password for, or an application and a password, okay? So first we want to...
Sorry, does the true have to be capitalized? I'm sorry, does it matter?
Yes, it does matter. Yep, so that's a really good question. So Python only recognizes this as a Boolean true or false value if you capitalize it. All right, if not, it means nothing. It's just a variable to it. So please make sure it is capitalized. Great question. Right. So first thing we want to do is we want to write website equals, and we want to ask the user to input. Please enter a website you want to store a password for. There we go. We can even go further slightly and say website/application. Because some people might use it as an app. We can still store it under website. It makes no difference really, because this is just a variable name. Right. Now, whatever the users entered, remember it's stored within website. Okay, so if they entered Google, it will be stored as Google. If they entered WhatsApp, it will be within WhatsApp. Now we're going to create a password. And we're going to ask the user to enter a password for this website. So we're going to say input, and we're going to create an F string this time. So remember, an F string is used so you can insert something directly into this bit that you're typing in. So please enter the password for...
You not share the screen.
Can you guys see my screen?
Yeah,
You can
I
see
can
it.
see it. I can see it, yeah.
Yeah, Sajid can see it. Samia, can you see it now?
Oh,
Okay, I think everyone else is able to see it. Maybe try and just, I'll pause for a second. Maybe try and just leave the meeting and join back again.
all right, yeah.
All right, we're just going to wait for Samia to join back. So just a quick recap of F strings while you're waiting. Right. Samia, can you see that okay now?
Yes, yeah, I can see it. Thank you.
No worries. Right. So we're going to say, please enter the password for, and we're going to write curly brackets like this. And we're going to put in here website. Okay. So what that's going to do is, because we're using an F string, it will place whatever the user's entered here so they know that that's the password they're entering it for. Just keeps it nice and clean. Okay. Now, what we're going to do now is we're going to hash the password, okay? So because we want to save it as a hashed password, we don't want to save it as a password within our dictionary. We want it to be secure. So what we're going to do is we're going to write hashed password. So our hashed password is going to be equal to, and we're going to hash the password, or we're going to write secure password, actually. Secure password is equal to hash password. And so within the hash password function, we're going to pass in password, whatever the user's entered. So whatever the user enters now here, it'll jump to this part of the program. It's going to hash the password. It's going to return this hashed password, and that's going to be now stored within secure password. Does that make sense? So This means it's going to quickly whoosh up here to this function, do the function, store it here in secure password. Everyone clear with what we've done? Right. I'm just going to demonstrate this. Don't try this yourself. I'm just going to print. I'm going to show you what this does. Right. Don't try and attempt this, because if you don't write the break properly, it will just crush your program. Right. So you can see here, please enter a website application you want to store a password for. So I'm going to write google.co.uk. Press enter. And please enter the password for google.co.uk. So I'm going to write codex and I'm going to press enter. And you can see here, codex is being converted to this value. Okay. 57B, E4, C4, whatever. Okay. Now, if I run it again, if I try it for Instagram, but if I enter the same password, you can see here it's the same hash value. Okay, so it's always going to be the same hash value if you use the same bunch of letters. But if you use a completely different set, you can see it comes up with something else. And this is what's going to be stored within, we're going to store it in our dictionary, okay? We're going to store the username, so we're going to store Reddit alongside this, rather than storing the actual password itself. And that means if anyone hacks into our passwords, all they see is this. They can't access our actual, they can't actually access our information, which is extremely, extremely secure, okay?
I have a question. If you gave the same password for Reddit and Google, would it give the same encryption code or the different encryption code?
Exactly the same. It's not an encryption code. This is just a way.
No, like, so if you said perfume for all, if you use the same password for all your apps, does the program give exactly the same encryption number code, the 37 ECF thing? Does it give that back? So that's why you shouldn't use the same password for lots of things.
Not necessarily. That's one of the reasons why you shouldn't, but as in when it's being stored, this means nothing to anyone, right? 37ECF.
Yeah.
All that's being stored in your passwords thing will be like this. So it will be Reddit, colon, and 37, blah, 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 blah. And then it'll be Google, colon, 37.
Yeah, my question was basically, if you use exactly the same number, not password, does the 37H, does that change, or is it always going to be the same because you've used the computer recognize a repeated password and give it the same code?
That is right. Yes. So it will, when it's using this algorithm, it will always come up with the exact same hash value. That's right.
Okay, that's what I was trying to say. Thank you. Sorry.
No worries. No, that's okay. Good question. And remember, this isn't reversible. So if someone has this, they won't be able to then work out its perfume. Okay. So the only way you can check it is by entering, when you know what the password is, you can write it and check against our simple password manager to see if it comes up with the same value. So I'll show you that slightly later. But okay, so right now, what I'm going to do is I'm going to zoom in again. So this is where we left off. Secure password equals hash password password. Right, now what we want to do is, now that we've hashed our password, we want to store it within passwords, okay, which is our dictionary. So we're going to say passwords and our index. So our index is going to be website, okay? So we're going to store it within website. So we're going to store that website is going to be equal to, and we're going to say it's going to be equal to the secure password. All right, so if the user enters Google, in the dictionary, it's going to create Google, colon, secure, whatever the password hash is. Instagram, colon, whatever the password hash is. Okay. And then once we've done this, we're going to say a lovely message to the user. Password. Saved. Now, finally, just to finish this last bit section off, we're going to ask the user if they want to continue. Okay. So we're going to say another equals, we're going to say input. Do you want to save another website password? And we're going to give them options so that we don't need to error check this as much. We're going to say either write yes or no. And if they say yes, if another equals, you write 2 to check. So if it's equal to no, then we're going to say, if they don't want to continue, we're just going to say, thank you. And we're going to break.
Rashid.
Yes, Adele? Everything okay? Do you have a question? Oh, okay.
Gosh,
Okay, so just while we're waiting, I'm going to just quickly zoom out and I'm just going to run our program so you can see what the expected output is. So please enter a website. So if I write google.co.uk, I want to enter the password as perfume. Do you want to save another password? So I'm going to write yes. So please enter a website application you want to store a password for. I'm going to write Instagram. Please enter a password for Instagram. I'm going to write T. Password saved successfully. I'm going to write no. I don't want to save another one. And it says thank you. Okay. And that's everything in terms of our saving. So then we've just got one final bit to write and then we're done with our program. So just everyone have a go and give me a thumbs up when you've managed to do this, please. And it's working for you. Please give me a thumbs up. Awesome.
Can you just make it, I just want to see the end of the line on line 15, what you've put at the end.
Let me just move this up for you. There you go. Is that okay?
That's perfect. Yeah, I just want to see what you've done there. Okay, I've done the same thing. Perfect. Love it.
Awesome.
Before I press run.
Awesome. So you guys can now, because we've done our break, you can run it once. Just try it out. Just see if it all works as expected. And once it's done that, just give me a thumbs up. So you've got the same, if not similar, output to me. Just for you guys to see, I'm just going to quickly show you what the passwords dictionary looks like. Again, you don't need to try this. Don't try this, actually. We don't want to stop the program. But if they say no, thank you, I'm just going to print out the passwords dictionary so you can see everything that's stored right at the end. Okay? So if I say, there we go. Right, if I say Google, right, if I say no, you can see here, this is how our dictionary is stored. So you can see it's Google, and then this is the hash for it. WhatsApp, this is the hash for it. Okay, so this is how we've actually stored it. So you don't like, just for you to see what you're actually building. Okay, so we don't want this. We don't want to show the user this. It's not very user friendly, but that is what happens. Okay.
Can I ask another question? The yes, no. If they type the yes or the no in capital letters, will that be read as well, or does the capital letter have to be the same there?
Well, okay, so that's a really good question. So right now we've not actually handled that. So we can actually handle this ourselves. So what we can do is right now, if you entered it in capitals, it wouldn't recognize it. Okay, it will, if the answer is not exactly no, it's going to assume it's a yes. Okay. What we're going to do is to handle this, where it says if another, we're going to just write dot lower, open bracket, close bracket. Okay. Now what that's going to do is whatever the user enters, if they enter, I'm just going to show you at the bottom here. If they enter no like this, if they enter no like this, if they enter no like this, it's going to just convert it all into lowercase. So that all of that would become no. So that when we compare it and it's in lowercase, it works perfectly fine. Okay.
So if I make the yes, no's in capital letter, like the yes in line 21, if I make that a capital letter, do I use a different prompt?
That's right. So if you did this, you'd write dot upper. And then you'd need to change this again to capital. Okay? Because we want to compare it to the uppercase.
Hold on. If another upper.
So dot upper or dot lower just converts it all into uppercase or dot lowercase, respectfully.
I see. But what happens if I do mixed case, like the big capital Y and...
Yeah, so anything you write. So if you entered yes like this, if you entered yes like this, if you entered yes like this, however you enter.
If the question is yes, the first one. If line 21, I write the yes like the first one. What happens then?
Like this.
Yeah, exactly.
Okay, so this is a lot harder to handle. So what you need to do is we need to check each character individually, or we need to check one of them and then the other one, etc. So it's easier to just force it to all be upper or lowercase. Okay.
Yeah, thank you.
Yeah, but at this point, it doesn't matter. If you did write yes or no like this, if we're converting it to uppercase and we're checking it as uppercase anyway, it doesn't really matter what the user enters. Does that make sense? Because the user's only seeing this. Regardless of what they enter, we're going to change it to uppercase anyway. Okay, so if you wanted to write the yes or no like this to make it look nice, so that's fine.
Okay, all right, perfect, thank you.
Right.
Okay.
I'm going to bring it back to lower because that's what most people have done. So I'm just going to leave it like this. But again, yeah, the user enters yes or no. However they enter it, it's going to convert to lowercase now to check. So that should work fine. Right. So our next bit now, okay, we're going to break out of the loop again. We're going to create another while true loop. Okay, so this is our second while true loop. So this happens first. We're going to ask store all the passwords that they need. Now the second part is here. We're going to ask the user to check if what they have entered is the password they have saved. Okay, so right, first, what we're going to do is we're going to write the website to be checked. So the website to check is going to be input. Please enter a website or application you want to check. Okay. Right. So we're going to write a condition here because if the website they've entered isn't within the passwords list dictionary, there's literally no point checking it, right? Because if it doesn't exist, if it's not in there, we can just tell them straight away that it's not in there. There's no point checking through each item to save it's in there. So very easily, what we can write is if website to check, this is what's lovely about Python. It's very close to English syntax. If website to check in passwords. So if it's in passwords, then we're going to bother doing the rest of it. If it's not in the passwords dictionary, there's literally no point. That means they've not stored that website.
Oh.
Okay, so again, remember your colons in the right place. So if website to check is in passwords, what we're going to do is we're going to ask the user to write in the password for that website that they want to check. So we're going to say entered password is going to be equal to input. So the user's basically, please enter your password for. Oh, so we're going to remember to make it an F string. Please enter your password for, and we're going to write in the website to check. Right. So first they enter the website they want to check, then they enter the password they think is the right password for that website. So that's going to be entered password. And then what we're going to do is we need to hash this. Okay. So very simply, just like we did for the password when we stored it, we're going to say secured. So whatever they've entered, we're going to hash it to check against the other hash, okay? So we're going to hash it by saying hash underscore password. And we're going to put in the entered password this time. So last time we put in the password that they actually entered when they wanted to save it. This time we're going to enter the entered password, which is the second time where they're trying to guess the password. So we're going to hash that in the same way. And then what we're going to do is we're going to check this against what we had stored in password, okay? Are you with me so far? Do you understand what we're doing logically? The thought process behind what we're doing right now? Or is any bit confusing you that you want me to go over again? Nope. Okay. I can see one thumbs up, which is good that we're understanding everything so far. Right. Right. Okay. I'm going to keep going until someone interrupts me if you're confused. Right. So what we're going to now do is we're going to do some checking. So we're going to say if, again, we're going to say if inside our passwords dictionary, if the website to check, because that's going to be whatever website it is there, if that's equal to, so if the password for that is equal to the secure entered password that we've hashed, we're going to say, so if they match, we're going to say password is correct. All right, very simply. And we're going to say delete out there. So else, so in line with this if, we're going to print incorrect password. So that means they've entered something incorrect. Okay, and now I'm going to write one more else in line with this if. And if that means so this whole section was for if the website was in the passwords. If it's not, we're going to say print no password stored for that website. Application. Okay, so again, just quickly learning through the logic. So we're checking, we're going to write a website that they want to check. We're going to ask them if that website is in what we have stored, if it's in our password manager, we're going to say, we're going to ask the user to enter a password for that website, and we're going to hash that password. And then we're going to say, if for that website, whatever the password we have stored for that, if that's equal to the secure entered password, we're going to say password's correct. If not, because that's what they've written, and if that's equal to whatever that's being stored already, we know that's correct. If not, we're going to say incorrect password. If the password wasn't even in the, if the website wasn't even in the passwords dictionary to begin with, we're just going to say there's no password stored for that website. Okay. The next bit is very simple again. We're just going to basically write this entire section again. In line with the else, we're going to say, do you want to this time check another password or website? Yes or no. If another is equal to no, we're just going to say thank you. Okay. And we're going to break. Right. So I'm going to leave that there for you guys to all write. And if you have any questions, now's the time to ask about what we have done. Or if you're clear with everything, then that's fine. But that's the end of our program. Actually, while you guys are writing, I'm just going to quickly demo what the program is, and then I'll let you keep writing. So welcome to our simple password manager. So we're going to go with Google as usual. I'm going to go with pairs. I'm going to go with yes. I'm going to go with Facebook. I'm going to go with oranges. I'm going to go with no. So
Can you expand the left-hand side again while you're doing that? Sorry.
yeah, that's fine. There you go. So let me just move this across so you can see both. There you go. So please enter a password that you want to check. So now if I'm going into Google, if I enter google.co.uk, it is inside the thing. So we can say, please enter your password for it. So let's say I enter something incorrect. I don't remember whether it's oranges for Google or not. Let's try oranges. It's going to say incorrect password. Do you want to check it again? Check another one? Yes. I'm going to enter the website again. I'm going to check google.co.uk. Oops, sorry. I think I pressed exit by mistake.
But can I just ask a question? Under another, you've got a capital yes, no. On the previous one, so okay, so you can do capital letter, first letter, capital yes and no. Is that right?
So again, it doesn't matter what the user enters. So this is just for the user.
But it doesn't. That's okay. Okay. I see what you mean. It doesn't.
Yeah.
We can write a capital letter in that place, and it doesn't matter. Okay, cool. Thank you.
Yeah.
I know I'm obsessing about small things, but
no. It's good to understand what we're writing. So it's good you're asking questions. That's absolutely fine. Right. So I'm just gonna go google.co.uk pairs. So no. So check google.co.uk. So if I enter pairs, you can see here it says password is correct, okay, because I've entered the right password. So we know that our program works absolutely fine. If I want to check another password, let's say I check Facebook, Instagram now, we know that we haven't stored Instagram yet. So you can say no password stored for that website or application. So we know our program works fine. And then it says thank you at the end. So that is our very simple password manager that uses hashing.
Can I see, can you just scroll up so I can see the line numbers? Or scroll so I can see the thing. And you go up just a little bit higher. I just want to see line 16. 1 second. It doesn't like what your line 22 is for some reason. It says syntax errors. Okay, got it.
Were you missing the bracket?
No, I was missing a semicolon.
Ah, there you go.
Oh, it's still. Oh. No, it doesn't like line 17.
Anyone managed to complete it yet? Give me a thumbs up if you have. Oh, Anthony's done. Awesome stuff, Anthony. Well done.
Okay, thanks.
Oh, no worries.
Oh, no, I better go back.
Okay. Yeah, absolutely fine. Right, I'm just gonna go into Adele's code and we're gonna have a look at it together, see what the issue is, if there is another issue. Okay. Oh, Sajid's done as well. Amazing.
I get a message, yes is not defined.
Okay. That means where you have yes is not defined. Have you written if yes instead of if another dot lower or if another?
No, I've done, okay, so I've done if another dot lower equals no, print thanks, break. And no, print, yeah, no, I've done no.
Okay. Just bear with me 1 sec. Why don't you share your code with me and I'll have a look in a sec.
Okay, I can copy and paste it to you and send it to you from my other, how do I do that?
So if you press share button, if you press link, copy the link and you send it to me, then I can have a look. Right.
And I share it to you.
On the chat.
I can't because I'm on a different computer.
Ah, okay. Right, so if you just write in the letters for me at the end of your share link, if you just write that in the chat, if you just physically write it in, it should only be a couple of letters. And
Okay,
then I'll
perfect. I'll do that, yeah.
Yeah. So please enter the password. So I'm gonna say, okay. So okay. Yeah, this is the issue here. It's because you've written 265 and not 256. That's all it is, Adele. String subject does not. Okay, and then here it's passwords. This is our dictionary that we're trying to save it to. Okay, so we need to just make sure that that's the dictionary that we're saving it to.
T5.
And then entered password Yep, here, just about the password wrong. Uh, yeah. That's it. So those were your issues there. Hopefully that helps, Adele. Let me know if that's thing. So you just needed to correct your spelling for entered password. You needed to change that to passwords. So there was an S missing there. And you just needed to change that to 256, not 265. No worries at all. Right. Ingrid, I'm just gonna have a look at yours now. Yeah, it's because here you need to have this within your speech marks, because this is what we're printing to the user.
Okay, so hold on. Another. So I just need another semicolon or whatever they are.
You need to move the speech mark to the end. So this needs to be within the
You know
speech.
what? I do that, and then I move to the next line, and then it disappears, which is weird. And then I put kids. Okay, I'm gonna try one more time.
Okay.
I think I'm not. I did okay. Another input saved, another password. It looks identical, and it doesn't. Oh, I have to remove the previous speech mark. Got it.
And then here as well, Ingrid, I can see that you've got a dash instead of an underscore on line 23. You need to change that to an underscore.
Yeah. Okay, so I'm gonna go run.
Oh, I think you're missing a line of code. Yeah. Yeah, here. You've hashed the password, but we've not stored it in the passwords dictionary. You need to store that in. So you're missing line 18.
Hold on. So def hash. Well, where's it? Let me just see. Well,
So
true.
your
My
password.
line is slightly different than yours. Website password. After secure password, I have to put password. That's great. Thank you.
All right.
I could not have done this on my iPad. I'm glad I shifted. Even this is hard.
Yeah. It is a lot harder on a computer.
Can
Sure.
I ask you to please explain line by line if you have a time?
Yeah, of course.
Thank
Right.
you.
So first bit, what we're doing here is
It now doesn't work since I've just made that last change.
okay. What's the error you're getting?
Trace back. Okay. It's a spelling error, supposedly. Okay. 1 second. I'll just change that.
Yeah. Right. So you can see here that firstly, what we're doing is we're printing a simple password manager. Then what we're doing is we're creating a dictionary, as mentioned before, to store the usernames and passwords. And the reason for that is because you have a key and a value pair, so we can store information in pairs, so username and password. This whole function here, what that does is it hashes the password. So if you look back on the recording, so because I don't want to take up too much more time, the hash password basically hashes the password, and then it stores that as a hashed value. Okay, so the reason for that is just to make things more secure. All right. So this section here, what that's doing is first what we're doing is we're going to ask for a website to store the password for. We're going to ask the user in this section all the passwords they want to store, basically the websites and password combos. So whatever website they enter, whatever password they enter, we're going to hash that password and store the website along with the hashed password. Okay. Then we're just going to keep going with that until they say no, and then we're going to break out of that. Then here, what we're going to do is we're going to ask the user to check what they've entered against, or check a password that they've entered. So let's say they've stored 10 passwords for Google, Instagram, Facebook. They want to check what their password was for Instagram. We're going to ask them that here. So they'd enter Instagram. Then if they have stored for Instagram, then that's perfect. We can check that. If they enter a website like, let's say they enter Snapchat, and Snapchat's not within it, then we're just going to say no password stored. If they do enter Instagram, which is what we were looking for, then we're going to ask them to write in what they think their password is. If that is correct, we're going to hash that. We're going to hash that first, and then we're going to check if that is equal to whatever we have stored for the password. We're going to check the hashed values against each other. If it's the same, then we know what they've entered is the password that they've stored before. So we're going to say that's correct. So then they know, oh yeah, my password for Instagram was pears all along. If not, we're going to say incorrect. So they know that's not the right password. And then we're going to keep asking them if they want to check it again and again until they say no. And then we're going to break out of that. So hopefully that answers your question, Saja.
Yeah, just for 1 second. In the very beginning, there is the password equal with curly brackets. Is because of is like object type of array.
So it's a dictionary. This is just an empty dictionary that we're storing the values of.
Yeah, but you do curly brackets because of is like going to be like an objected array, or what's
it's just a dictionary. That's just how you store a dictionary. It's curly brackets in Python. It's not an object. It's just a dictionary. Yeah. So for
Okay.
this, you use square
In
brackets.
case
for-
I have to understand what is dictionary.
Oh yeah.
Like
Okay.
what's
Oh, I think. Oh, you missed that at the start of the lesson. So a dictionary is if I go into our bear with me 1 second. Right, this is a dictionary. It's an unordered collection of unique stored values in key value pairs. So just go back to the recording and have a look, and I go through it in a bit more depth. But it's kind of like a dictionary in real life. So you have a key value and a pair that matches. Okay, and this is a dictionary.
But that's what I actually meant it. Just I couldn't say it like that. I call it like an objected array
Yeah.
or something
Okay.
like.
Yeah, that's right. So yeah, no, it's a dictionary. So this is
Okay.
exactly that's what you had in mind. So the usernames would be this bit, the key bit, and the values would be following that. All right.
It's basically like a one-line Excel.
Kind of like a one-line Excel, yeah. Like a table.
Thank you.
No
Yes,
worries.
thank you.
That's absolutely fine. Good question. Right. Everyone okay now? So that is the end.
Can I ask one thing? I put in a yes when I want to check in. I put in a no. Please enter Apple website to check. I put in a no, and it doesn't. It says, "Do you want to check another?" It comes back with, "Do you want to check another app or website?" It doesn't break.
Okay.
But I have a quick look. I haven't changed the code since, so maybe have a quick look. What's causing that? So it works out saving the password, everything, and then it goes to
check it.
Password save, that's fine. Save another password. Yes, no. And no, it doesn't break. It comes back with no passwords can be found, which means clearly that it's dumped the code all the way down to the very bottom.
Right. Okay. So let's walk through this. Right. So Google password is, we're going to say pairs, for example. Save another password. So this is working fine for you? No?
Yeah, so say yes, and that's fine. And do no.
Okay. So we're going to go Google again. No passwords can be found. Okay. That's because you were missing your line. That's fine. Do you want to check another app or password? No. Thanks.
Well, see, when I got it, please enter app or password. I got oh, this is to check. No passwords. Okay. All right. See, what happened is it asked again.
Okay. So I think
After
the
password.
bit that I might be asking again is the first bit is when you say no, that's fine. So it stops and then it's asking you which one you want to check. All right. So it's going to the second part. So I think that's working fine.
Yeah. Okay. All right. I mean, I'll let you. I'll play with it. I'm sure that it's somewhere something small.
No problem. That's absolutely fine. So remember, first it does all of this bit where it saves the passwords and then it will automatically go on to, if you say no here, it will go on to the next bit here. So please enter the one you want to check. So I believe your one is working okay, but just have a look in your own time. Right. And if you have any questions, just let me know. Right. So I'm just going to go back onto the slides to go through your assignment.
Okay. I found what it is.
Okay.
All right, assignment.
Right.
Here's another error.
Okay, awesome. That's fine. Oh, you figured it out, right? Or do you need any help?
Well, I'll have to figure it out. Yeah.
Okay.
I think it's a typo. Don't worry.
Okay. Right. So how to upload your code. So I'm just going to flick through this quickly, but you guys are familiar with this now. Right. Week 4 assignment. So basic secure voting system. So you need to write a program in Python that does the following. So the program should start with a welcome message and display a menu of options: voting for a candidate, viewing voting results, or quitting the program. Users should be able to vote for a candidate by selecting their candidate of choice from the list. Each candidate should be represented by a unique identifier. When voting for a candidate, users should input their name and vote. The vote should be hashed using a secure hashing algorithm. So what I'm going to say is you need to store your candidate along with their votes in a dictionary, okay? Right. So I'm just going to show you what the program should be like, what we're basically looking for. Sorry, I just need to figure out a way of not showing you the code for it. Right, okay. So you can see here, secure voting system, vote for a candidate, view voting results, or quit. So if again, it doesn't need to look exactly like this. You can amend it and make it. So if I view voting results now, you can see that each candidate has 0 votes. If I want to vote for a candidate, I want to vote for candidate 1. So the ID is 1. So I'm just going to go there. You can come up with the ID yourself, or you can just make them write candidate A, that's fine. Or you can give them a specific one that you want to do. Enter your name. Vote submitted. So then if I view my voting results, you can see that's 1. Okay. And then quit program. So relatively straightforward. So that is what we want you to work on. Okay. For your assignment. Again, it will all be on it's on this week's, it should be on this week's recording, and it will be on the Notion page with all your assignments as well. Okay. And a little breakdown of what we want you to do. Remember, the Saturday sessions are still on. Right, so just go back onto here. Saturday sessions every Saturday at 10 a.m. via Zoom. Not compulsory, but it's your space to ask questions. Community support, put any questions in here. We'll get back to you as much as possible, as quick as possible. Oh, something's wrong with my computer. Right, there we go. And yeah, that's it, I believe. Right. So that is everything. Do you guys have any other questions? One question we'll get to homework. How would we get feedback on it? For instance, it's submitted a working code, but you may know a better, cleaner solution. I'm admitting to the task and solution would be different. Okay, so when we go through and we are marking your assignments, so when we are doing that, I think we'll probably start that probably week 5 onwards, or probably a bit later. We will give you feedback, all right? And we will go through that. And also we might, what I'll do is at the end of the course, I might send some model solutions. I don't want to send them straight away because I don't want to give out the answers, but I might send some model solutions on the best way or the more optimal way of doing it. But the beauty of these assignments is you can go about it your own way. But I'm happy to give feedback and just say this is a good job, or you can change this, etc. Okay?
Okay. Yeah. Are you going to write correction on GitHub?
No,
Did you
no.
see
I
it?
will send you that personally, and then we will send you
Oh,
that
okay.
separately, and then we'll write it. It's yet to be decided exactly the manner of how we'll do it, but it will be done in some way. Okay?
Awesome. Thank you.
No worries.
Thank you very much.
That's all good. Any other questions? Well done, guys. I know this was quite a hard thing to concept and put together. So well done for everyone bearing with and powering through. And yeah, I know we've ran over again, so I'm gonna let everyone go now. Don't want to take up any more of your time, but I'll see you on Saturday if you have any other questions, or following Monday. All right? All right.
Bye.
Take care, everyone. Bye.
Thanks very much. Thank you. Bye-bye.
No worries. Bye.